You thought you were rid of me. So Brian and I were talking all about sort of maps and infrastructure and all these big, heavy things. And you are running a company where you guys are using deep learning to kind of try to figure out from the inside of the car what it's like to kind of navigate these kinds of maps. Is that right?
Yeah, so I founded and am president of Drive.ai, which is a deep learning company. We are reimagining how to build a self-driving car startup from the ground up, from perception, motion planning, to controls, all using deep learning, which is a software, the most sophisticated form of artificial intelligence today.
Tell us a little bit about deep learning. What makes it the most sophisticated kind of artificial intelligence over and above the other kinds?
Yeah, so it's a form of machine learning, and it thrives on big data. So it likens to how the brain works today. So it's made up of a neural network, and when I first took my computer vision class, it was based on hand-designed algorithms. So you would really have to recognize different edges. So one of our first assignments was to recognize a chair. So you'd have to recognize 4 legs, a seat in the back. And all those algorithms break when it's upside down, when it's a stool. And for some reason, the human brain can generalize so well when it sees a chair and all the different variations of it. And that's a high-level description of how deep learning works. So you give it a bunch of examples. It's like a toddler, and it starts to train and make up its own set of rules.
I always wonder, when you're doing work like that, I mean, you just spoke to this a little bit, but does it give you kind of a renewed appreciation for the sophistication of the human mind?
Yes, yeah, because even today, there are all of these things that people fear AI or push the boundaries of AI, and we're really right at the cusp and the start of artificial intelligence, where you really ask it a bunch of binary questions like, is this spam or not? Is there a face in this picture? Yes or no? And these are kind of like the where we're currently at in AI. And deep learning has broken the benchmarks in every industry since 2011, from ImageNet to speech recognition. Everything that runs on AI is basically deep learning right now. And there's a huge shortage of deep learning expertise coming out in the field, but it's a very rapidly growing, emerging field with huge promise. And we're applying it. We find that the best way to apply deep learning is for self-driving cars.
Yeah, so speaking of self-driving cars, I know one of the problems that you all are working on is how to get a car to read kind of the, maybe not emotions, but intentions of human beings. And I wondered what makes that so hard?
Right. Humans are amazingly complex, how our mind works, how quickly we change our decision-making. And in a car, there's so many nonverbal social behaviors that happen, whether you're honking, whether you're waving, whether you're making eye contact with the child crossing the road. The number one problem, I think, facing self-driving cars today is general public trust. And for us, we address that problem through a number of different ways. One being having the car communicate what it sees and what it recognizes and its intentions, so that humans around it can accurately make a decision based off of that. So I think number one, an autonomous car needs to be able to say it's in autonomous mode, and that you recognize this and that you feel safe crossing in front of that car. The second thing is that it needs to tell you what it's going to do. So humans look at subtle cues, such as the wheel turn, to know that the car is about to turn right. You get the head nod to know that it's safe. But when you take the driver out of that equation, what does an autonomous car now look like? And do you trust to walk in front of an autonomous car when there's no driver there indicating to you? I think even among humans at an intersection, it's amazingly hard to be like, you go, me stay, or I'm going to go. So I feel like there's this nonverbal dance that happens, and for self-driving cars, that needs to happen. I think most people's first encounter with a self-driving car will not be as a passenger. It will be as a pedestrian or a vehicle around the car, and it needs to be very, very transparent what the car is going to do, so that you can also maneuver around it.
Why don't we go to an example of that? And we have a pair of images that show a scenario. So here we have our two rendered humans in the crosswalk. And there's this car saying safe to cross. Now, can you tell me about some of the design choices that you guys made here?
Sure. So at Drive, we want to get self-driving car technology on the road quickly. We are a B2B company. We retrofit fleets to be able to drive selected routes. We don't think that self-driving cars is going to happen everywhere overnight. So it's with these select partners that we are going to drive on selected routes. So on this route, we have this kit with audiovisual cues. So this will indicate to pedestrians and vehicles around it what the car's intention is and what it's going to do. I always say that with deep learning, you are now able to redesign and reimagine sensors on the car and also ways for the car to communicate. I always say that the horn is the worst design feature on a car. There's no directionality, it's monotone. You have no idea what the car's intention is. So with deep learning, if you can understand intention and you can understand context, you can now appropriately target certain sounds. You can play with frequency, tonality, to give a polite honk versus a get out of my way, I'm going to crash into you. So for us, we found this to be necessary to gain trust and also to give context, and that's all enabled through deep learning. If you can understand what the car sees, then it can act appropriately.
Will there, in fact, be a sort of angry car flashing light at some point? Or
Yeah, I think at Drive, the number one thing is that we want to safely get from point A to point B. But at a higher level, we want to reimagine our relationship with cars. So a win to Drive is AI in and out of the car, which means Knight Rider on the inside and Herbie on the outside. And I think people in the 50s loved the car, and since then it's been more of an annoyance. But if cars can be reshaped through software, particularly through AI, we want people to love their cars again, love cars that they're in. It would be great to be able to get in and out of every car and have that same experience carried with you on the inside. And I think it's important on the outside that it is a non-threatening car. The design choices are for it to be very friendly and for people to really trust and understand what the car is going to do.
I was wondering, like looking at work like this, I wondered if there were historical precedents for when human beings have had to interpret a whole new set of visual cues in their environment.
Yeah, so we're seeing it anytime that humans and machines have to interact together. There are, I think we're moving into a stage where anything that can get smarter will get smarter as we move from the digital world into the combination of physical world. So all these human-machine interactions will need to be reimagined. I've been a roboticist for the last 15 plus years. Started off in underwater space and spent a long time in surgical systems. My goal is to have, I think working with robotics has taught me what it means to be more human. We understand our own strengths and weaknesses, and then also where robots can complement us. So I think as we move into this next decade, there needs to be careful consideration with how we interact with these systems. I think there's a lot of different examples of signals, and like augmented reality is definitely one where you have a machine and sounds and signals need to be interacted with.
Yeah, when you describe your career, it sounds a bit like my 6-year-old son when he talks about like what he'd most like to do. You did undersea robots, space robots, and then surgical robots. What made you switch to driverless cars? What was the appeal?
Yeah, so I spent, when I was a kid, if you asked me what I wanted to be when I grew up, I didn't know. But I had thought I might want to be a doctor because it was the best way to help people. I spent 4 years volunteering at Southwest Medical Hospital at Washington State, and I learned that a doctor works really tirelessly to help one patient at a time. But when I found out about the pacemaker and how that can scale to save millions of lives, I knew I wanted to be an inventor, and that was really an engineer. And I've always worked at intersections of humanity and tech that have huge impact. So when I was working on surgical systems, I kept trying to think about different ways to have less intervention, to preventative medicine. And it was really that the largest problem facing young adults today are car accidents. 1.6 million people die every year from car accidents, 33,000 in the US alone. And for me, the biggest way to help save lives was to stop people from entering into the operating room to start with. And self-driving cars is really the biggest problem facing society today.
Is that right? What are the numbers behind that? I mean, is it how many traffic accident deaths?
Yeah, so 1.6 million is worldwide fatalities. So that's not even including the number of fender benders. I think these are just accidents. People say texting is the new drunk driving, and we are getting more and more distracted. Humans are terrible drivers. It's undeniable, and people don't like to drive. And I think as we move into this world where there's zero autonomous cars to 1% to widespread adoption, I think the current bar should be better than human driving. And when we talk about city infrastructure changing, it could almost be that there's an autonomous lane barrier that blocks human drivers from pedestrians because it is so dangerous to have humans driving on the road. I don't think that we're going to, I think people say that we might have a law to stop humans from driving. I don't think that's happening anytime soon. But I do think autonomous cars are going to be out in the road in select areas. And, I think there's lots of different ways to start reducing the number of accidents that way.
Brian said something interesting when he was out here, and I wondered if you shared his view. It sounded like you did just now. You said people don't like to drive. And if you went back, 30, 40, 50 years, people would think that statement was outrageous, right? I mean, there's this whole mythology around the automobile as this kind of unique technology of freedom. Is the idea now that was an artifact of a very singular time? When automobiles were first invented, and now most people see them as kind of an irritating appliance.
I completely agree. I think the internet has fundamentally changed the way that people connect, and now we thrive for more connections. A car gave us a limited sense of freedom, which was highly appreciated back in the 50s and 60s, where people named their cars, and it gave them a chance to get out of their communities. But now people have, they can travel by plane, they can connect on the internet, they have new ways of connecting, and the car seems, in a way, archaic in that sense. I think as we move to this next generation, it will definitely change. I think young people don't get excited at the age of 15 and a half to go out and get their permits anymore. Me alone in this last year since we've started this company have gotten numerous traffic accidents, fender benders, my side mirror got knocked out. There's been a lot of things, and I think cars are more of a pain than anything. And spending time parking is a large issue as well.
The pedestrian scenario we were just talking about is kind of a pragmatic one. I was wondering, in the wider field of robotics, since you kind of have a very panoramic view of that field, where else will we see this kind of engineered understanding between machines and humans?
So I think we're going to start seeing robots into the wild. I view the self-driving car as the first robot that most people are going to interact with. And I use that term robot very loosely.
Is a toaster a robot?
Yeah, exactly. So I think people have already seen you call something a robot if it doesn't have a purpose. So once it has it, your washing machine is a smart machine. Your dishwasher it can be called a robot. But I think as we move into this next phase, good design needs to be coupled with hard tech. Self-driving cars is a really extremely hard technology when you pick your sensors, when you design your maps, when you navigate around people. But one thing I've learned is safety comes first. But if you build the safest system, it's always one that sits in the corner and does nothing. So I think these products need to be very well designed so that people love them and use them, and it actually solves the problem. If you talk to someone who's ridden in a self-driving car, the first 5 minutes are amazing and it's awesome, and you watch the steering wheel. After 5 minutes, it gets boring because you essentially just turn into a passenger and people look for the next novelty. I think with self-driving cars, people are seeing other types of UI problems like motion sickness, and a self-driving car will drive slightly differently. For us, it's the value of the driver, and getting rid of that is one thing. But I think there's all these new opportunities that can happen with self-driving cars. We imagine a world where every business can now be on wheels. It is a computer on wheels. They could be like vending machines driving around. You no longer have to go into the city to buy something. I think people live in an on-demand lifestyle where you want everything coming to you, and Drive.ai's mission is really to bring everything to you.
As machines sort of develop a more sophisticated ability to read human emotions, is there an upper limit to that? Are there sort of subtle tonalities or facial expressions or ways of using language, metaphor, that are just inherently creative that a machine will never be able to glom onto?
Yeah, I don't want to use the word never, but I think we're very far off. I think humans are able to understand social etiquette very, very well. I think a robot navigating through a cocktail party is a tremendous challenge. I think robots always get dinged for not having emotional intelligence and also being able to understand and interpret the softer side of things. Even self-driving cars, when you get cut off on the street, there's something magical about that hand wave that comes up, and all of a sudden I feel like that person has acknowledged that they've cut me off and it's okay. I think a self-driving car will need to have not only safety aspects in it, but social etiquette on the road so that it doesn't make everyone else feel road rage and a loss of general public trust.
Are these kinds of, and not just in driverless cars, but in all kinds of these various ways where machines are trying to understand the intentions of humans, how are those going to be generalized across culture and across borders?
It's a tremendously hard problem to get a global understanding of things. You have to surpass literacy. You have to surpass people who might not be able to read the signage. So we do audiovisual coupled together. There needs to be redundancy in things. You'll notice that a traffic light, the way it's designed, not only changes color, but also location. So I think there's a lot of different subtle design considerations to be had. We want the child to be able to understand. We want the elderly who might not be able to see. We want different cultures and what different signs mean across different cultures and different locations. I think there's a lot of local intention and understanding, and then also a universal signs. So I think things like the pedestrian man walking is something that is universally understood, and we start from a place of where there has already been standards.
I've heard you say before that humans, unfortunately, are designing some of our very worst flaws into our AIs. Can you say a bit more about what you mean by that?
Yeah, so I think there's a discussion in AI that's happening where AI systems that learn so well from data is actually becoming strongly biased. So it brings out the worst and the best in humans. Microsoft's Hey was released out for 24 hours and learned from crowdsourced data and turned extremely racist and sexist in the matter of 24 hours that it had to get pulled offline and have a timeout. And and I think it's a lot of this is, it has to be very well designed early on, and there are inherent biases, and AI and software, like it always does, will amplify everything that goes in. So we have to be very mindful when we are designing our systems and building our teams.
Is there a potential silver lining there where sometimes, tech has some pretty serious diversity problems, and you can sometimes see among tech executives a kind of denial that's set in about that? And I wonder if, or rather a tech determinism, like, oh, we'll just fix this problem with technology.
Yeah.
And might it be the case that if AI is sort of this ugly mirror of some of our worst attributes, that actually might push us forward?
Yeah, I always say that it shouldn't be harder to hire diverse candidates than it is to build self-driving cars. We here talk about the possibility of self-driving cars, and yet have such a hard time in Silicon Valley hiring diverse candidates into our teams. And I think especially with AI and self-driving cars is a life and death situation where if you do not think about these biases early on and how you build your data set that you train on, I don't want to be responsible for a self-driving car that might have a higher probability of hitting one ethnic group over another, or not being able to think through certain types of people or animals. I think this is a huge problem in Silicon Valley in how they, starting from the hiring process. It's gone past denial at this point, but more just acceptance, and that's not good enough. So we do have to think about it, especially with AI, which is such a newer technology. There's a fair chance to have no barriers, because everyone is, this is just right at the start of it. So it's not like you'll have AI researchers who were coding AI since they were 10. This is different now. For my generation, a lot of people got into computer science because of their love of video games, and I think it starts with how we do outreach and how we think about the impact that society can have.
Carol, thank you for being with us today. This
You're
has been
welcome.
wonderful.
Yeah.